Problem 3. Time of flight. So what we are shown here is a cliff of height h from the ground. This is the ground. And a ball is thrown from the top of the cliff upward in the upward direction with the initial velocity v0. What will happen? The ball will deaccelerate due to the force of gravity which is acting down. So that's the force of gravity. The acceleration is down, g. So in this part of the motion, which is from O to A, the ball will deaccelerate because g is acting down. So the ball will deaccelerate, and finally from A to B on hitting the ground, the ball will accelerate due to g and finally will hit the ground. So now to compute the total time t and this big height h, we just divide the motion into two legs. One is the leg from O to A, and then finally we consider the motion from A to B. So we'll again use the standard formula, that is xt is equal to x0 plus v0 t plus half at square, and vt is equal to v0 plus a t. Let's solve this equation first. Suppose at t equal to ta, the ball reaches the highest point A, basically where it starts changing the direction and starts accelerating downwards. So the velocity at time ta is 0 because the ball finally comes to rest, and then it has to change the direction and start moving downwards. So the velocity at A has to be 0. We substitute these values in this equation, so we get vta is equal to v0 plus acceleration. Acceleration is g, but in the negative direction of velocity. So we'll write it as minus g, and time is ta. vta is 0, v0 is v0 minus g ta. This implies ta is equal to v0 over g. So it takes time v0 over g to reach the highest point A. We'll now substitute ta in this equation. X of ta, x0 is 0 plus v0 is v0, ta is v0 over g plus half, acceleration is minus g, ta square. This will v0 square over g. Let me rub it because we need more space. v0 square over g, I beg your pardon, minus half g v0 over g whole square. So when you simplify this, this will be v0 square over 2g. This is xta, and note xta is nothing but the height of the point which is at the maximum height from the ground from the topmost point of the cliff. So let's call it h1. So which implies h1 is equal to v0 square over 2g. So this solves one part of the problem, that is big height h is nothing but equal to small h plus h1, which is equal to h plus v0 square over 2g. So this solves the part 2 of the problem. Now to solve, so this is the answer of the part 2. Now to solve the part 1, we need to find the total time of the flight t. Note that total time of the flight t will be t from the origin O to A, so that is ta, plus the time it takes to freely fall from A to the ground. Let's call it t free fall. Now we already computed t free fall in the class, and that is equal to 2h over g, and h we have already found from this equation, so it will be 2h over g plus v0 square over g square. So now substituting the value of t free fall in this whole equation to get the total time t, we get ta, which is v naught over g, plus t free fall, that is 2h over g plus v naught square over g square. So that is the answer to 1.